Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem. Form the partial differential equation from the relation 2z equal to x square by a square plus y square by b square by eliminating the arbitrary constants a and b. So here we are given a relation 2z equal to x square by a square plus y square by b square, right? 2z equal to x square by a square plus y square by b square, where a and b are arbitrary constants. So we need to form a partial differential equation from this equation by eliminating the arbitrary constants a and b. So for that, we are given a relation. Consider as equation 1. In order to form a partial differential equation from 1, we'll partially differentiate 1 with respect to x and with respect to y. So firstly, I'll begin with partial differentiation with respect to x. Okay, it's partially differentiating 1 with respect to x. So here I'll write direct steps, and after completing the problem we'll show you the number of steps, okay, in detailed way. Fine. Now partially differentiating 1 with respect to x, right? So here y will be treated as constant and z is a function of x and y, so we'll get 2 into dou z by dou x equal to constant 1 by a square into partial derivative of x square with respect to x is 2x plus partial derivative of constant with respect to x is 0. Since we have a notation dou z by dou x equal to p, so let's replace dou z by dou x by p. You'll get 2p equal to 1 by a square, that is 2x by a square. Otherwise it's okay. 1 by a square into 2x, which gives us, you can just take this 2x to LHS, then you'll get 2p by 2x equal to 1 by a square, where 2 gets cancelled, and you can write this as 1 by a square equal to p by x. Consider as equation 2. Okay. Well, now partially differentiating 1 with respect to y. So here we need to partially differentiate 1 with respect to y. So x is treated as constant. Now we'll get 2 into dou z by dou y. Since z is a function of x and y, so we'll get dou z by dou y here equal to partial derivative of constant with respect to y is 0 plus constant 1 by b square into partial derivative of y square with respect to y is 2y. This gives us 2 into, since we have a notation dou z by dou y equal to q, right? So let's replace this by q. You'll get 2q equal to 1 by b square into 2y, right? Now bring this 2y to LHS, then you'll get 2q by 2y equal to 1 by b square. It's 2y, okay? 2 gets cancelled and you'll get q by y equal to 1 by b square. Or you can write it as 1 by b square equal to q by y. Consider it as equation number 3. Right? Now observe 1, 2 and 3. Here our motive is to eliminate constant from 1, okay, in order to find the required partial differential equation from the given relation, right? So here, in order to eliminate a square and b square from 1, just observe 1, 2, 3 here. So from this we can say that 1 by a square can be replaced by p by x and 1 by b square can be replaced by q by y, right? So while replacing, we can eliminate a and b. That is, by replacing 1 by a square and 1 by b square, we can eliminate a square and b square from the given equation, and this results to some equations, say f of x, y, z, p, q equal to 0, right? It does not involve any arbitrary constants a and b, and that will be the required partial differential equation. So let's see that now. We have 2z equal to x square by a square plus y square by b square, right? Now substitute. Two and 3 in 1, we get 2z equal to, we can just write 2z, equation 1 as 1 by a square into x square. We'll write the first term of RHS as 1 by a square into x square, and second term can be written as 1 by b square into y square for our convenience. Now replace 1 by a square by p by x and 1 by b square by q by y by 2 and 3. Okay, then this becomes 2z equal to p by x into x square plus q by x into y square. So here 1x and 1y gets cancelled. It's y, okay? Fine. Now this gives us 2z equal to px plus qy, which is of this form. Therefore, 2z equal to px plus qy is the required partial differential equation. Okay. This completes the problem. Now we'll see in detailed way. Given relation 2z equal to x square by a square plus y square by b square. We have considered it as 1, right? Now partially differentiating 1 with respect to x. So apply dou by dou x on both sides of this equation. Right? We can write this as 2 into dou z by dou x, since z is a function of x and y, equal to dou by dou x of first term x square by a square plus dou by dou x of the second term y square by b square, right? This gives us 2 into, since dou z by dou x equal to p, so let's replace it by p. You'll get p into, here 1 by a square is constant, so we can write it as 1 by a square into dou by dou x of x square plus, since we are partially differentiating with respect to x, so y will be treated as constant. Here y square by b square is treated as constant. So partial derivative of a constant with respect to x is partial derivative of a constant y square by b square with respect to x is 0. This gives us 2p equal to 1 by a square into partial derivative of x square with respect to x is 2x, right? You can cancel 2 here itself. You'll get p equal to 1 by a square into x. So bring this x to LHS, will get p by x equal to 1 by a square, or we can write this as 1 by a square equal to p by x. Consider as equation number 2. See, you got the same thing. Okay, now partially differentiating 1 with respect to y. So apply dou by dou y on both sides of this equation. Dou by dou y of, they are just part. Since we are partially differentiating with respect to y, so here x is treated as constant, okay, and z is a function of x and y, so we'll write it as 2 into dou by dou y of z equal to dou by dou y of first term x square by a square plus dou by dou y of second term y square by b square, right? This gives us 2 into dou z by dou y equal to, here x square by a square is constant since we are partially differentiating with respect to y, so x is treated as constant, so we'll get partial derivative of constant with respect to y is 0, plus here 1 by b square is constant, so we can write this term as 1 by b square into dou by dou y of y square. Okay, this gives us 2 into, since partial derivative of z with respect to y equal to q, we have the notation, so we are using it here. So just replace 2 dou z by dou y by q, you'll get 2q equal to 1 by b square into partial derivative of y square with respect to y is 2y. You can cancel 2 and take this, bring this y to LHS, you'll get q by y equal to 1 by b square, or 1 by b square equal to q by y. Consider as equation 3. Now observe 1, 2 and 3. From 1, 2 and 3 you can say that 1 by a square can be replaced by p by q and 1 by b square can be replaced by q by y. Okay. So by substituting 2 and 3 in 1, the arbitrary constants a and b gets eliminated, right? And that results to the required partial differential equation, which is of f of x, y, z, pq equal to 0 form. Okay. We have 1, 2z equal to x square by a square plus y square by b square. Now substitute 2 and 3 in 1, we get 2z equal to, we'll just write this as 1 by a square into x square plus 1 by b square into y square for our convenience, since 1 by a square equal to p by x and 1 by b square equal to q by y by 2 and 3. Right? So let's replace 1 by a square by p by x and 1 by b square by q by y. Right? Then this becomes 2z equal to 1 by a square can be replaced by p by x into x square plus 1 by b square can be replaced by q by y into y square. Here 1y and 1x gets cancelled and this gives us 2z equal to px plus qy, which is the required partial differential equation. Therefore 2z equal to px plus qy, which is of f of x, y, z, pq equal to 0 form, right? Where it doesn't contain any arbitrary constants. So this is the required, and also this is of f of x, y, z, p, q equal to 0 form. So this will be the partial differential equation, that is the required partial differential equation. This completes the problem. Well, we have seen a partial differential equation, that is a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.